Hello friends, so we have come to the next concept of the Laplace transformation of the circuit element. So what will be the Laplace concept of the circuit if circuit is connected in the parallel or series resistance is in parallel to the capacitor. So how to calculate by the by the using Laplace system. So see that what will be the happen. So that is Laplace transformation of the circuit element. So that first of resistance, okay. First of resistance, if one resistance is there, so if we calculate that Laplace of the resistance, so what will be the happen? So V of t is I of t into R is there, so it is V of t upon I of t equals to R. So that is Z of t is R. So if we have taken to the Laplace like Z of s, so there is no frequency change in that, so there is no change in the resistor, so we can write that Zs is only R. So if Laplace of resistor, there is no change, Laplace of resistor, there is no change, so it is a only R. Okay. So second part is capacitor. So what will be the capacitor is there, like capacitor. So there is some line is there. So there is a two part of capacitor is there. One part if capacitor is not already charged, and second part is capacitor is already some initial voltage. So first part, assume that capacitor having no initial voltage. Okay friends, so first part A, we assume like A, assume capacitor have no initial charge. So capacitor have no initial charge, so it means no initial charge is there. So one capacitor is there, and that I of C current is going in the capacitor, and some voltage is here like V of C into T. So what will the happen? What will the current in this capacitor? So like C into dC by dt. Okay. So that what Laplace of what is the Laplace of dCV by dt? It is differentiation of voltage. So what will be the Laplace of that? Like S into Vc into Vcs and minus V of t. Okay. So at the initial there is no voltage is there, so that part is 0. So that I of Ct is what? C into S into Vc into S. So like Ic of t into V of Ct. So like what is that? I of C into V of C into S is there. So if we like calculate like here, so when V of S into I of S, so that will be changed like 1 by Cs. So impedance provided by the capacitor in Laplace transform. That impedance is provided, like that impedance provided by the Laplace transform. Okay, so there is another part. When capacitor is already charged, you can see that if it is not seen, so we can see that impedance provided by the Laplace transform. So another part is there when capacitor is already charged. So what will happen? So we can see that what will be the happen. Okay, so sorry for disturbing. There are some issue is there, some fan issue is there. So like what is this? Capacitor is having some initial voltage, like capacitor is having some initial voltage. So like that capacitor, okay, and that capacitor is C, and there is a plus V naught is there, and I of t is going from in this capacitor. So what will be the current is there? Current is 1 by S. So like C into we have differentiate already, S into V of S minus Vc at 0. So that voltage is there already, have some charge, some voltage 1 by Cs. So we can write that S into Vc of S and minus V naught, because Vc is Vc at 0, that V naught voltage is there. So that what will be the happen, like ICS into CS Vc into S minus C into V naught. Okay, so C into V naught. So we can manipulate that. So what will be the happen? What will be the happen? So CS into VCS equals to IC of S plus CV naught. So VCS equals to ICS upon CS plus CV naught upon CS. So like CC cutting, so like only I of C and CS plus V naught by S. Okay, so this kind of current is flowing in the circuit. See this voltage. Okay friends, so you have, I think, understand that this kind of voltage is this. So where here we can write that how circuit is coming like A to B. So it will be converted like one voltage source, or one voltage source and one capacitor is there. So here I of CS is there, and then after V naught S, which is written is here, and 1 by CS, 1 by CS is there. So that is converting, and if we can also write in the form of parallel. So that is current CV naught, and that capacitor is in parallel, and 1 by CS and VCS, and capacitor the current is ICS, so that V S into CS, okay, CS, then what will be to happen? IC, that is ICS, and minus CV naught. So after that ICS is VCS plus CV naught. So that is the another part of capacitor. So this kind of also in the inductor also, so we can study inductor also, what will be the happen in the inductor when it is charged or not. So that is third part, like inductor. If inductor is not charged, so that L and VL into VL of t, and current is going I of t. So what will be the VL equals to L d into IL of t by dt, so that VL into L in the bracket of S into IL of S minus IL of also present here. There is no current present before of the inductor, so that current will be the 0 L into LS into LS. So VL upon VLS, we can say that when we have taken the Laplace transform, so like LS only. So that, so if we can write that one inductor, so it will be changed like what? It will be changed like, if we change the Laplace transform, so L into S, okay, like A, B, and A and B. And what will that happen when inductor is already charged? So we can see that part also. So that if one inductor is here like L, and some current is there like I of L into T and A and B, so that it converted to the inductor, and some voltage source like L into I naught into B, and here IL into S, so A and LS, okay. So like VL of S into IL of S minus LI naught. Oh, sorry, this kind of thing it is not showing, sorry for that. And it will be also we can write that what in the parallel form, like current source, and in the parallel of L into S, in the parallel of inductor, so that I naught S is here and L into S, and here B into S, and a current is going IR of that, so we can write that I into L of S like what, Vs by L into S plus I naught into S. So that, okay. So in the next lecture we will solve some problem on that, that is connection of L and C in the parallel series by the Laplace or without Laplace. So thank you.